Hello world and welcome to another episode of FooBar. Today we are talking about the challenges, the future of observability in serverless applications. If you want to know more about serverless, cloud computing or software engineer practices in general, subscribe to my channel in the red button below. I post videos on Tuesdays and on Thursdays. So let's get started! This is another episode in my series, This is not a podcast. I have talked with a lot of people and today I'm super excited to introduce you Taavi. He is the CEO of a company called Dashbird. It's a Estonia-based company, so very close to where I live, Finland. So I'm always super excited to show some local talent. I can say Baltics and Nordics are very close to my heart. So I'm super happy to chat with Taavi. We talk about observability, we talk about the challenges, why it's so hard to do with serverless applications, how he sees the future, and so many things. So let's go to the interview. Hello and welcome to another episode of This is not a podcast. Today with me I have Taavi Rehemägi from Dashbird, a company from Estonia, so I'm super excited to have someone from just crossing the river, Baltic Sea, small, 80 kilometers, we can call it a river. So welcome Taavi to this episode of This is not a podcast.
Yeah, thank you, Marcia. It's really great to be here, and I've been following your show for some time, so excited to be finally sitting here, and yeah, I hope this will be a good conversation.
Yeah, I'm pretty sure that we will have a lot to talk because we are going to chat about the challenges of observability in serverless applications. So I think we have quite a big and broad topic to cover. Yeah. But first, I would like that the audience know a little bit more about you and about Dashbird and what you're doing.
Yeah, absolutely. Myself, I've been a programmer and a developer and working with engineering teams for pretty much half of my life now. I've worked at multiple startups, scaled them, built products, managed engineers a bit as well. And prior to founding Dashbird, I was actually one of the engineers responsible for scaling a pretty large-scale serverless application. And my kind of experience goes back to serverless with 2015, 2016. So it's 5 years serverless development experience. I enjoy building cloud products, talking to other cloud users, and kind of thinking long term as well about the space, and what we do at Dashbird aligns with kind of how I hope this space will evolve as well down the line. So. Yeah.
You started also the AWS user group in Estonia, so that's pretty nice way to speak to other.
Yeah, that's been growing pretty well. I think the cloud adoption, it didn't start off as quickly here in Estonia, but now in the last couple of years, it's been actually really good.
Yeah, I think maybe for persons watching that don't know much about Estonia, because it's such a tiny country, it has a lot of startups and a lot of tech booming there. So it's quite interesting to see the space there.
Yeah, I mean, even Skype that we're using right now was actually engineered in Estonia. So
exactly.
That's when it all started for us as well. Was we, a couple of Skype founding engineers were from here, and then we had TransferWise and a lot of other.
Oh, TransferWise is from Estonia as well.
Yeah, TransferWise. Wow. Polt.
Nice.
A lot of.
Yeah, how many people live there? It's 1 million and something?
Just over 1 million, actually. It's 1.3 million.
Wow. So, So now, new fact about Estonia. And one of I think the most popular facts is this digital government that you have there. That's one of the things that I think make Estonia appear in the map of...
I think the other is most unicorns per capita.
Yeah, exactly. So it's an interesting place to to be.
Definitely.
Yes. So tell me a little bit about Dashbird. What you're doing there?
Sure. So Dashbird actually got started when our team, a lot of the core members actually in Dashbird We were building serverless applications together, and for us it was early 2016, 2017 when really not just like the tooling didn't exist, but also best practices or kind of the general know-how of how to piece together those kinds of applications really existed back then. So our kind of what enabled us to do Dashbird was that we were actually running a really high-scale serverless application in production at that time already. We had big enterprise customers. We had a lot of surface area, and obviously, like operating that in production was quite difficult for us. And
having a serverless production application in 2016 was very painful.
We had our own version of the serverless framework because that didn't really exist back then as well, or it was just getting started.
It was kind of starting by that time because I started with serverless in 2016, and we have, I think, 0 point something. It was not even like. Really.
So we had a really similar thing actually. We didn't like open source it for some reason. We just didn't think of doing that. Didn't think that we would need it or something. I don't know. But then Dashbird came soon after, actually as a side project. And it took us like 2 or 3 months to get something running, and it we got like over 100 users in the first month.
So when you started, when you launched it for the first time?
It was 2017.
So quite early, because I think more or less by that time I was going live with my first serverless application in production, and monitoring was a pain. It was, I think, from the whole serverless process, it was the most painful thing of all.
What we found also was that we kind of, with deployments or those kinds of things, you kind of solve it one time, and then you kind of have a process to do it, while monitoring was kind of getting worse over time when the scale got higher, when the changes in the architecture and the load got larger. So it was escalating rather than de-escalating.
And I think at the beginning, at least when I started, there was this concept that serverless was like a monitor as a normal application. So there was not really like any special tooling or any special components or any ways to like monitor the I don't know what is happening in your other services that are not Lambda, for example. So it was kind of frustrating because it was just like, my serverless application is comprised of 20 million different moving pieces, and I can only see if my Lambda code executes or not.
That's exactly what was the first thinking. The other one was that DevOps will disappear. Is that okay? So if you don't have to operate servers, then you're pretty much set. Like you just deploy something into the cloud, and it will take care of itself. So I think that was the other thought process going on at that time as well.
Luckily, we had dropped that because I think we still need people to look at over our applications. It's a different looking at. It's not maybe babysitting the servers anymore, but we still need experts.
I think the focus area shifted from like code level instrumentation and like that kind of APMs into something else that we are still figuring out what it is, but
definitely. And at least when you're using these managed services, a lot of the complexity now is in the configuration on the integration level. So that's the type of things you might want to test, and you might want to observe if everything is flowing as it should. It's not that you want to monitor if Dynamo is up and running. Most probably it will.
Yeah, exactly. Yeah, it actually becomes, there's multiple fundamental kind of new problems that we're seeing. I think one is a data problem, that you have such large amounts of data in terms of like log data, but also metric data, tracing data, configuration data over such a large surface area that, that's a really new problem. Because back when container-centric architectures, it was like a couple of containers, it was much more in one place. So
and you could see the logs inside your container, or you could test locally and whatever. But now It's like, as you said before, you might have 500 different AWS resources, or not even AWS resources, some third-party resources that are composing your application for, I don't know, using 10 different services, and everything needs to move, and you need to understand what is happening there. So
exactly, and I think the other thing is then actually the know-how, or like services are so specific that you end up using a lot of different ones.
Yes.
And many of them have, the failure scenarios are different between different services. And when you're just adding like 5 to 10 services together, it takes some effort to understand the nature of these services as well. So
yeah, and I think that's super valid, like how services fails. That's something, in general, people always think about the happy flow. Oh, I can connect this.
Yeah.
But how to make sure that, and it's not that, again, Dynamo is not working, it's just that maybe your configuration is not right. So how to handle that, and how to make sure that that you catch it on time and the right
exactly.
moment.
Yeah, so I think, obviously when we started Dashbird, we didn't think so deeply into the problem set, but over time, kind of as we were seeing a lot of users, I think what at some point the thought process we had was like, okay, so what are, let's map out the fundamental problems that people are seeing, and like try to work backwards from there, or like, let's work backwards into the problem set, let's define those, and then come up with a hypothesis for the product. So
besides the data visualization and all this mess of services, what other problems have you seen?
Yeah, so as I said, like a large surface area, and then the first problem is just managing the data, right? Having the infrastructure to eat all of that data, or just make it available, make it like interrogatable, so that you can interrogate the data, you can ask questions from the data. The other thing is like what we are focusing on is covering all of those failure scenarios dynamically with alert coverage, or detecting automatically if something goes wrong. So in that term, first part is something needs to process all of that data that's coming in. So it's a big data problem. On the other hand, it's identifying the specific failure scenarios for each service. So I think, being aware of what can happen and pre-building those alarms for organizations is kind of alert management in general, I think.
You have some kind of set of alerts that are there when something goes wrong.
Yeah, exactly. So what we are doing is dynamic alert coverage, and obviously it's kind of opinionated, but also so there's two types of, like, the way I see it, like the first type is like binary failure, or like everybody under the same way, that it's okay, your DynamoDB isn't responding anymore for some slow. No question, that's a failure. But then there's like opinionated stuff, like, okay, how much API gateway latency is okay for you, or any of those kinds of opinionated stuff. So we try to do both. The first part is easy, the other part is not as easy, but just as good.
Latency in general is one of the big things to monitor in this type of services, in this type of applications and systems. And it's not only inside maybe the AWS ecosystem, because maybe the services inside there is small latency because it's all running in the same region. But when you talk with third-party services, or when you talk with your own services but through the internet, then it's when it becomes very interesting to know how to manage that.
Yeah, exactly. And it's also like, serverless is highly concurrent, at least Lambda functions are. And so different scales have different effects on downstream services as well. So it's kind of, it can happen at any point almost as well. So you can run into service limits. So those kinds of things are like, people don't always think of or map out all the failures, and it's also a lot of work to have coverage for like edge cases or something that you kind of don't expect to happen.
Exactly, and I think with serverless, they say you should test in production, and it sounds scary, but I think the bulk of your test, they should happen continuously, and your monitoring and observability tools are there to assist you, because production is the only place that you will have the traffic and the scale from your real, like not a fake one, because a lot of these services, as you say, they really depend on the amount of requests that you have and how they behave together. So, for example, it might not be the same how Lambda function perceives the request, and maybe how some legacy system, if you connect this Lambda function to this legacy, you might be killing it after 2 seconds. In your test, might work, but not in reality. I remember one service we were in my previous life, we were working with a company that was validating chat. And I don't know how they picked that company, but there were not that many around in the market. So I was using a serverless architecture, and we could basically have all these validations done in parallel, and they were promising that they could take hundreds of requests per second, but I was throwing them thousands of requests per second, and they were like, no, we cannot handle them.
Yeah.
They have to, basically, because they want us as a customer, they have to re-architect their side, because they were promising something, and okay, that's something I can do with no problem. Send you 100 requests per second. In Lambda, it's as easy as.
Exactly. And I think you made like a good point that with serverless, you have to kind of test in production. And I think, I don't put my name in like bold letters that say test in production, but I think at the same time, one of the key drivers of serverless adoption is the faster kind of code to market ability, or kind of the ability to deliver differentiated value faster. And to do that, I think the less kind of, it is sometimes the best to test in production, but lower the risks of the impacts.
But I think for testing in production, I'm not meaning that you need to test everything in production. I'm just meaning that you need to have a continuous set of tests that are running all the time somehow, that you have alerts when things go wrong, that you can understand and understand the data, so you are very confident that if this happens, I know what is happening. I know that everything is fine, or I know that something is not fine, because it's sometimes very common, at least with traditional applications, that you just wait for something to fail, but in serverless and in distributed system, things fail very often, and it's very normal that things fail. So you need to be very proficient with all your tools, and they will fail in random ways, that one day it will fail this thing, and maybe tomorrow it's a totally different thing.
Yeah, so I think it comes down to kind of, first part, lowering the risk. So maybe like rolling out deployments like gradually, try like 10% of your function at first, and then the rest. And the other is kind of what gives organizations confidence is that if something goes wrong, the ability to react quickly.
Exactly.
So, the first part is that you understand that something is wrong, which means basically having monitoring coverage. And then the other is, detecting the root cause of the issue and what's causing it as well. So
having a good alerting system that lets you know.
And I think that eventually will contribute to the kind of the development speed through kind of confidence. And if I do make a mistake in my code, then it's not going to escalate to a really high level.
No. And I think, as you say, that's so integrated with the deployment strategies. If you have safe deployments, and if you have an easy way to roll back, because that's something also a problem in some companies. It's very hard to roll back changes, because everything is so coupled together that you make a deployment and 27 systems change, and everything is like, oh, now you want to roll back, but we changed it, 27 databases, and you're like, okay.
Yeah. Exactly. So that's not like reducing the risks, really.
No. So everything comes together. Like all your tooling is very important. That works very well. Like your deployment strategies and your easy, fast way that you can deploy 20 times a day if you want, and keep on testing and seeing in production if it's working fine, and and make everybody. So we were talking about a little bit before this the interview about what are the pillars of Dashbird, and I like your approach there for these 3 big pillars. Can you tell us a little bit about them?
Sure. So as we see, so there's a couple of different opinionated kind of theories that we are basing also the pillars as well, or the product hypothesis. So the primary is that 5 years, 10 years into the future, application development will look like people or engineers piecing together their applications out of single-purpose managed services in the cloud. Yeah, like basic Lego blocks. And what we're seeing as well, one of the trends that's pretty interesting in Dashbird is the percentage of compute in an architecture is decreasing because the different parts that are used to be built with Lambdas are being replaced with some services. So that's how we see the future, and that has led us into 2 kind of fundamental directions. First is that we do not instrument any code currently, and we don't have any plans to do it. Rather, we focus on all of the data that's already available. So if you look up observability, what it means is that the system is producing enough information already to make the state or to understand the state at any given time. But what we think is lacking is, it's the data problem that you have such high amounts of really verbose data that, even though you have it somewhere, it's really hard to actually understand. And what we're doing here is centralization of that data.
And sometimes all these Lego puzzles are not coming from the same place. It can be you have you're using AWS as your cloud provider, but then you're using Stripe, and you're using Auth0, and you're using MongoDB Atlas. So if you want to see the whole holistic view of your application, then you need to go into each of these individual things, and they don't tell you the full picture. So
exactly. Yeah, and so actually that's also that's an interesting point, is that first part of that is just centralizing that data. The other is speaking that language, like the language of Stripe or the language of Lambda, whatever. So kind of what we're trying to do with alerts and also with visualization is translating the signals into kind of a standard format, in a way that, okay, we understand if it's failing, we understand how much it costs you, and that kind of translation process as well. So
the developer don't need to go and understand what this table means, that it's a little bit different than this other table.
So the developer doesn't need to know the deep know-how into failure scenarios, or they should, but we still cover and we automatically detect, so they don't have to build it themselves, or they don't have to anticipate the known failures that might happen. So that's the first pillar, is basically having the infrastructure to ingest data from anywhere and to visualize it and to make it navigable. The second part is dynamic alerting, which I already kind of touched, but basically we want to anticipate any failure that your architecture can have or your compute resources can have.
And how do you do that? Is it specific for every user, or do you analyze the patterns, or it's something that you decide, okay, this should be between these limits? How you get that automatic alerting?
So that's a good question. So the first step that we do is for logs. We have log pattern matching and pattern recognition. Like a simple example here is if your Lambda function has a code exception in any of the languages that it supports, then a trace, stack trace is logged out into CloudWatch. So we recognize that and log that as a failure and aggregate those failures over time and give you kind of this incident view where we see like not just the failure itself, but all the invocations where it happened, what was the trace at that time, those kinds of things. So that's for logs. We're in the process of launching this feature that would do that for a lot of AWS services that are producing logs, is pre-building such filters. For metrics, we have this library of kind of continuous checks, but also like conditions for if we can detect if a queue is growing, or if your API gateway latency is higher, or if you have any failures, then that's something you would want to know. And it's a continuous process. We're always adding.
Oh yeah.
And we're listening to customers into seeing like what's really important for them, and
Yeah, that's super important. And then you mentioned that you have this kind of continuous rule checking engine or something like that. How that works?
Yeah, so I think that's the most interesting. It's also the most experimental. So what we've, I think the opportunity here is that we actually have so much data around the stack in terms of all the monitoring data we have, that we can detect non-binary failures where the situation is actually a combination of multiple different metrics that should be looked together. And like an example here could be that the queue is getting more items into the queue that are being processed over some period of time, and that could escalate into a delay in that side. Yeah. Or it could be like anything else, but also, so that's like monitoring non-binary failures or issues, performance degradations, but also we can monitor cost spikes and those kinds of things. The long-term vision for this is to be kind of a advisor for well architecting your cloud infrastructure. So looking at configuration data, looking at security, looking at compliance, looking at cost optimization. So a lot of that is actually doable based on the monitoring data and configuration data of the resources, and understanding different the relationships between resources and those kinds of things.
That sounds really interesting. That basically you could open a console and it can tell you, well, maybe it's taking too long, and are you thinking that it can suggest you ways to re-architect your application, or have some kind of things that you could read, or how you're envisioning this to happen in the future?
Exactly, and basically you could look at it like from like an alert perspective, or like, okay, here are the events that you should be looking at. But other way of quantifying it could be like reports on, so what's the overall security score for my microservice made with Lambda functions, and like what should I address here to kind of take care of it. So
because this, I think, is a great way also to educate people, because serverless is quite new in the space. I think now we are getting to a point that we start having some best practices, but still nothing is set on stone. And whenever you talk with someone, it's like there is no right answer. That's kind of something everybody's telling you, like there is no right answer if you do it this way or you do it. But I think at the end of the day, there are some good practices that are kind of take to better results at the long run. And I think it's great if there is a tool that, like, architecture framework, for example, inside AWS cloud, that tells you, okay, this is what you need to do, or this is what you need to check, and this is how you can fix it. So it's like an interactive way to train people and educate people in best practices, because sometimes telling that there is an error or something is wrong is not enough if you don't say how to improve it.
Exactly. Yeah. And I think what's good to see about the kind of the serverless market, or how things are evolving, is that a lot of those companies that started a couple of years ago with serverless are actually reaching to those levels where you actually have higher load. You depend on your architecture really, because you have a lot of users. So the importance of reliability engineering and monitoring is increasing for those companies. So I think, early on, a lot of us were experimenting and kind of building experimental stuff, and nobody really expected them to have to work all the time. But big, obviously, and people have been building really interesting, large-scale applications on serverless for years. But I think now we're seeing this kind of, at least the last 2 years, we've been seeing like maturity in the applications, like at the larger scale. So that's really like good to see.
Yeah, I'm super happy on the adoption that serverless is having in this last year. I will say so many people are jumping into this boat. I think now I have the feeling that we were early adopters and we moved to the next phase of the just more companies and less risk takers are starting jumping into these companies that first were like, serverless sounds cool, but I don't want to get into this new stuff. But I don't think now it's that new anymore, and there's so many people preaching and building things on serverless that I think it's less scary. So more and more are jumping into these technologies.
And I think, a part of what's contributing to this is also the early definition of serverless, at least where, really early, like 2015 definition of serverless was like...
What was the 2015 definition of serverless?
Function as a service, basically, abstraction of compute. So that was, serverless equals Lambda functions. And I think then it came like, okay, actually it's like anything could be serverless. And I think now we consider serverless applications that are, using DynamoDB, maybe SQS, but are using like, some other form of compute maybe as well. So
yeah, it's so hard to know what is the definition of serverless. I've been in so many serverless conference that they have 4 sessions on the definition of serverless, and it's like, I don't know anymore. But it's definitely for me these 2 things, compute and services. That's my definition.
Exactly. So it's no servers.
No servers. But then when you think about it, is Fargate serverless? What is I don't know.
I think it's a form of abstraction of compute. So if you look at the spectrum, I think Lambda functions are currently
more serverless.
The 100% serverless. I think Fargate is like 80 or something. So, but it's still like mostly serverless.
Exactly. Then you need to add this kind of dimension of a spectrum of serverlessness. Exactly. How you will say that. So then it becomes even more complicated. It's not just something is serverless or not, it's how much serverless something is.
Exactly.
It's like,
yeah, and I think that's when things really started to make sense for us, was where we were like looking at it as a spectrum and kind of looking at our customers as well, like, okay, they're actually, they're not companies who are serverless, meaning Lambda functions, using Lambda functions. They're companies that are operating in that part of the spectrum, and that helped us kind of define the problem set as well, or kind of to think about, and also it's simpler to think about the future as well, or to kind of try to project the future on like what's going to happen if you look at it that way.
Predict the future for me. What is the future of cloud?
I think it was in the 70s when I have to look up the quote exactly, but somebody said that it was an MIT convention, like some sort of a speech. It said that compute will be a utility, that means basically that it's cheap enough for anyone to access pretty much, and it's easy enough for anyone to access. And I think serverless is doing that. It's like one of the quotes that I don't agree with, but was that serverless is the PHP of this generation.
No.
It's simple enough to use for pretty much anyone, and I think that is true. Is that over time it will become easier and easier to use, and like building from Lego blocks.
Yeah. I think the cloud started this journey of compute as an utility when it made it accessible, because before you needed to buy these huge boxes, and you were just like, as a company, you were very limited on your budget, on how much you can invest in front. then cloud came and make it cheaper, but still you have to have so much know-how. And now we have this technology that basically you don't even need to know how to code in some cases. There is many serverless things that you can put block together and things happen. So
yeah, and I think that's gravity, right? I think the gravity is pulling towards that. More and more companies are obviously going online and building those kinds of applications. So it will there's pressure to make it more simpler, more scalable, more easier to adopt. And
for me, the simple thing I understand for like everyday persons that it's becoming simpler and simpler, but I don't think that distributed applications, the serverless applications, at least the ones that we are building today, they are simpler in the ways that I like it to be simpler, because I never like infrastructure and hardware and things like that, and configuring networks and things like that. But they're still very complex in the way that things move around that application and how and I think in a way they become harder to understand, because before, or maybe because our education system is not right on how we teach people to code. But when you go to school, you learn to code in like that. So when you go to a container or a server or a virtual machine, you can run, you can test your thing, you know what is going on. But then when you move to serverless, you go in a totally different paradigm. And after you leave maybe the hello world or basic use case, it becomes very complex for people to grasp. So I think it's becoming simpler to get started, but I don't know if the curve is becoming more steep.
I agree actually, and I wanted to say that as well, is that even though it's easier to get started, in some cases at least, it's just as hard, if not harder, to build like a really scalable, like really, really good version. I think it's easier, to be honest, but it's not. It's still hard.
It's easier because you're a developer, and that's the thing. Because we love making systems, and we think with our system head. But I think for someone maybe coming out from school with an education on coding in this kind of way that inside a box that you can run, it's very daunting.
Because the learning curve, you still have to learn all the services, right? And what they do.
And you need to learn way more services. And I think that's something that people are scared about, because before you could focus on your code in a way, but now you need to understand queuing, you need to understand databases, you need to understand, maybe you don't need to understand them in depth because the cloud provider is the one taking care of it, but you still need to kind of access that directly and give permissions and understand the cloud permissions. So the developer now has way more responsibility. As a developer, I'm super happy about it, but I think, at least maybe for you as well, serverless grab us when we were senior developers already. So for us it was like, wow, this is so cool.
Yeah, you're right. And I think it will take a couple of iterations more, kind of evolution more to happen.
And improve the education. I think at least that's one of the things I always try to do, because I think to learn, you just need to have better material to learn. It's not that you can expect people to learn something if there is no good material.
Exactly. That's also like part of like what we're trying to do at Dashbird as well, is provide a learning center or a cloud knowledge base that's actually free. You can access it on our public web, and basically what we've done is gone over all the services that we see our customers using, and kind of giving not documentation, but how things
good
to think
practices.
About. So, and it's been hugely popular. Actually, we didn't anticipate it to be that kind of well used, or I think educating the community.
It is. I think it's the key for I don't know how the future will be, how complicated it will get, but I think, at least from my perspective, it's all about educating the people on this way of building applications, because it's so different to build an application. When you had servers, you have virtual machines and containers, they are all in the same category of application building, but when you move to serverless, it just changed your perspective.
Yeah.
So I think it just needs better material there so people can consume it and learn.
Yeah, for me as well. I mean, the guys don't really let me develop anymore.
Oh.
So, one way for me to keep on top of all the kind of new things is, just playing around with them and writing documentation, and that's that helps me as well. So.
Yeah, I like to play around with services. I don't do production coding anymore, but I love trying new things out. So I cannot complain about that. Not having to maintain something live, it makes my night so much relaxing.
Yeah, it's good to sleep when you don't need to. You need to be the one to fix if something goes wrong.
Yeah, even with serverless, you still are like, will this work? Will there be a problem? It can scale indefinitely, yes, but there's other problems as well. Where people can find you if they want to chat with you or chat with Dashbird or with the user group in Estonia if they want to join. What kind of
so
communities?
you can reach me at Taavi@dashbird.io.
I will leave all the links on the description.
Yeah, Twitter. We have an intercom bubble on our public web where all the team is online. So
nice.
We try to answer as quickly as possible, usually in less than an hour. So
send that pictures so they make the team happy.
Yeah, send us pictures and questions and ideas.
Nice. So that's the place then I will put in the description box. And yes, thank you very much, Taavi, for your time, and I hope you have a great day.
Yeah, thank you, Marcia, for having me. It was really nice talking to you.
Thank you. Bye-bye.
Bye-bye.
This was the video for today. I hope you like it. If you did, give a big thumbs up. And remember to let me know in the comment box below who you would like me to interview in the future. There are some polls going on for my next interviews. Some of them I might already have done by the time you're watching this video, but there will be always some poll there for the following interviews I will be doing. So go and check and ask your questions, because that's the idea, that I can share the questions with the people I interview. And that's it for today. I'll see you in the next episode of FooBar. Ciao, ciao!